Hi there. In this video, we'll be learning how to convert a standard form of a circle into its center radius form. So to do this, we first recall that the standard form of conic sections is given by the equation ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, wherein a, b, c, d, e, and f are constants, or rather coefficients, while x and y are variables. For this to be circle, take note that the key thing to remember is that a and c must be equal and non-zero. So that is the thing that we first need to check in converting a standard form to its center radius form. If this form out here, if we have this, and that a and c are equal and non-zero, then we know that we can convert this to center radius form since this out here is a circle. So, given this, our goal, as you can see in the title or thumbnail of this video, is to convert this standard form into its center radius form. So, if you don't know what the center radius form is, you may check out the previous video in this playlist, so I can link that one around here. And in that, we talked about what the center radius form is. But essentially, the center radius form is given by this form, wherein h and k out here, this point represents the center of the circle, with the r out here representing the radius. So that is why it is called the center radius form. So, given that, to achieve this goal, our strategy would be first to recall the concept of completing the square. So, before I show how to do this, I could probably link a video around this one, since I have a video discussing how to do the completing the square method. Apologies for the loud noise. So continuing, related to completing the square, we first need to recall the PST, or the perfect square trinomials. So the perfect square trinomials, so what this tells us that if we are given a trinomial of this form, so a squared plus minus 2ab plus b squared, then if we see that the trinomial is of this form, then we can simplify this to a plus minus b squared. So we can simplify it to a square of a binomial. So from a trinomial, it becomes a square of a binomial. And so the reason that we need to take note of this is that using perfect square trinomial and completing the square, we can obtain x minus h squared and y minus k squared, which is precisely in our center radius form. So that is why we need to remember this one. So given this, let's now try to illustrate a little bit on how completing the square works. So if you already know this, you may skip to the examples part of this video, as I'll probably put the timestamps in this video. So to illustrate, so suppose we are given a squared plus minus 2ab plus with the last term missing. Our goal is to complete this trinomial of this form so that we can obtain the square of a binomial. So it's like completing this trinomial to make it a square of a binomial. So that is the idea in completing the square. So technically, our goal is to obtain b squared out here to match this form. Given only these two, how can we obtain b squared? Well, what we can do is we can focus on the middle term and we can divide 2a out here to obtain b. Or in other words, we divide this by 2 times a is the square root of the first term. So getting the square root of a squared, we'll have a. And so dividing 2 and a out here, we get b. Then squaring this one, we get b squared out here. So that is the idea behind completing the square. Now that this is out of the way, let's move on to our first example. So in here we are given x squared plus y squared plus 2x plus 4y equals 22. Before we start, feel free to pause the video so that you may try this one on your own. Okay, good. So let's start. So the first thing to do is to rearrange the terms out here such that the x's and the y's are beside each other. So we'll have x squared plus 2x plus y squared plus 4y equals 22. After this, since we want to apply completing the square, we try to put out a blank space out here as well in here. So again, our goal is to convert this out here into the form x minus h squared and this out here in the form y minus k squared to make it in the center radius form. So to do that, take note that to obtain this one, again we focus on the middle term. We focus on this one. So we have 2x. And again, what we do is we divide this by 2 times the square root of the first term, which is x squared. So the square root of x squared is x. So this simplifies to 1. Then we get the square of this, which is just 1 squared is equal to 1. So we'll have in here 1. So that is how we obtain this. For the y component or the y part, we do the same. So again, we divide this middle term by 2 times the square root of the first term, which is y. By the way, to make this more understandable, let's put a parenthesis out here, so it will be clearer what we are pertaining to. So the first term so this one is the first term in here. So simplifying this, we get 2. Get the square of that, and we obtain 4. So let's clear this one out. So we now have x squared plus 2x plus 1 plus y squared plus 4y plus 4. But we have a problem. observe that since we add something on the left side of the equation, take note that we also need to add that on the right side of the equation, since that is how equality works. So adding 1 on the left side, we also add 1 here, and we also add 4 out here. So simplifying this, 22 plus 1 plus 4 will give us 27 out here. And now we can apply the perfect square trinomial out here. So this one out here becomes x minus 1 squared plus, this is plus 1. There. And this one out here becomes y plus 2 squared. So essentially, to get this, we just get the square root of the first and the last term, and then copy the sign out here. So doing the same for this second. And this is equal to 27. Now this out here is already our center radius form. So we had already obtained the correct answer. But take note that if we want to get the center and the radius, just take note that this one is equal to x minus negative 1, and this is equal to y minus negative 2. While in here, if we get the square root of this one, it's equal to square root of 9 times 3, or equal to 3 squared. And so the center, where do we put this? Let's just put it above. So the center is given by the point negative 1, negative 2, with radius given by 3 square root of 3 units. So that is how we convert the standard form to its center radius form and obtain its center and radius. So good, I hope that one is clear, and I hope you got that one correctly. Let's move on to the second example. In here, we have 6x plus x squared minus 4y equals 68 minus y squared. Before we start, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's start. So again, the first step is to combine the x's and the y's beside each other. So to do that, we first move this y squared out here on the left side. So we'll have 6x plus x squared minus 4y plus y squared equals 68. Next, we rearrange these terms. So we have x squared plus 6x, and let's put a blank out here already, plus y squared minus 4y plus blank out here equals 68. Also, take note that our form out here isn't really in its standard form, but it's still in expanded form. So it's nice to try out how to do this. Also, something that I wasn't able to mention, observe here that the coefficient of x squared and y squared is equal and non-zero, since we know that that is something that we need to check in dealing with circles, so that we know that this equation is indeed a circle. So you may also check that in the first example, the x squared and the y squared has an equal coefficient. So continuing, what we do is we complete the squares. So from 6x, we have 6x over 2 times the square root of the first term, which is x. This simplifies to 3, get the square, and we have 9. So I did it quite quicker this time since we already have an idea on how it works. For the y squared, we have 4y divided by 2 times the square root of the first term out here, which is y. So we'll have 2 out here, get the square, and we obtain 4. By the way, apologies for the if you can hear the rain, since it's quite rainy out here. And since we add 9 and 4 out here, we do the same for the right side. So plus 9 and plus 4. There. After this, we then let's remove this first. We can then now apply perfect square trinomial out here. So this one out here simplifies to x plus 3 squared, and on the right we'll have y minus 2 squared. So again, to obtain this, we just get the square root of the first and the last term, plus copy the sign out here, and the same goes for the next one. For the right side of the equation, we'll have 68 plus 9 plus 4, or when simplified, that is 81. If I'm not mistaken, that's 81. So this out here is already our center radius form. If we want to get the center and the radius, again, take note that we can express this one as x minus negative 3 squared plus y minus 2 squared equals 81 is 9 squared. So we know that the center is given by these out here. So we have negative 3, 2, while the radius is given by 9 units. So that is the answer for this problem. Let's now have this last example. Again, feel free to pause the video so that you may try this one first on your own. Okay, good. So let's start. So this will be our final example. In here, first, observe that the coefficients of 2 and of x squared, rather, the coefficient of x squared and y squared out here are equal and non-zero. So this one out here is indeed a circle. Moreover, take note that every term out here, every coefficient and the constant out here is divisible by 2. So if we divide 2 out here, if we divide 2 out here on the left, so we do the same for the right, we can simplify this one into x squared plus y squared minus 4x plus 6y minus 15 equals 0. After that, we now try to rearrange this equation to an easier look on how to get and apply completing the square. So first we move this to the right, and then we rearrange these terms, so combining these two as well as these two out here. So we'll have x squared minus 4x, let's add a blank space out here, plus y squared plus 6y plus a blank space out here equals 50. And now let's try to complete the square out here. So in here, So we have 4x. What we do is we divide this by 2 times the square root of the first term, which is x. This is equal to 2, get the square, and we'll have 4. For the next one, we have 6y out here, so we'll have 6y, divide that by 2 times the square root of the first term, which is y, and we get 3. Get the square of this one, and we obtain 9. So we now have this one out here. But since we add 4 and we add 9 on the left side, we do the same for the right side of the equation. There. So this one out here, by perfect square trinomial, this is equal to x minus 2 squared. While this one out here is equal to y plus 3 squared. This is equal to 15 plus 4 plus 9 is 28. So this one out here is the center radius form of this circle. And if you want to obtain the center and the radius, take note that we can write this part out here as y minus negative 3 squared. And for the 28 out here, take note that square root of 28 is equal to square root of 4 times 7 or 2 square root of 7. And so, let's put here the center and the radius. So the center is given by the point 2 and negative 3, while the radius is given by 2 square root of 7 units. So that is the answer for this problem. Also, just to take note, if you want to verify that these are indeed correct, you may try to plug these equations in a graphing calculator, and you can see that the center is indeed correct and the radius is also correct. To formally end this, here's an exercise that you can work on. So we have 3x squared minus 30x equals 33 minus 3y squared. So again, this isn't really in its standard form, but still it is in its expanded form. So it's quite similar to a standard form. I just tried to rearrange it so that there's quite more challenge on how to solve this. So that's it. I hope you enjoyed and learned a lot from this one. If you have any comments, please don't hesitate to tell that one in the comment section below. So yeah, that's it, and that's all for this video.